Hello friends, today I am discussing a new topic of Castigliano, which is deflection of curved member. This is the second video on Castigliano's theorem. In this we will find the deflection of curved members. Watch the first video to know the basics of Castigliano theorem. So till now what we have done, friends, that if I have a beam which is not curved but linear with some load, and if I want to find the deflection, then I was using this formula. So what is my deflection? Deflection is integration of total structure with respect to m and then partial differentiation of that bending moment with respect to load applied at that point. So in this case it will be P dx over EI. Now for doing the deflection for curved member, I will change some of the parameters. What I will change? First I will change this dx. Here dx is this length. In the curved member, in place of dx I will be having ds. This is the small segment of the curved part. Now if the radius of this curved part is at O and the angle for this ds is d theta and this is the radius, then when theta is small, I can say that ds is equal to r d theta. So the first change which I will make in my deflection for Castigliano is that m into del m by del x, del m by del w, but in place of dx I will write r d theta. This is important. So what I will be requiring? Radius for this curved member. So r d theta over EI. First thing that you have to change. Second thing which you have to change, because now your integration is with respect to theta, so in place of integration of x, now you will be have integration in radians. This is the second thing which you require to change. Always put this integration in radian, never put in degrees. And what is the formula and how to convert degree into radian? The formula is very simple. 1 degree is pi by 180 radian. So x degree is equal to x into pi over 180 radian. So if I have 90 degree, then what is the radian? It will be 90 into pi over 180, that is pi by 2. So the second change which you have to make, so this is my first change, this is my second change. Now the third and the most important change which you have to make is the equation of the bending moment. Till now my equation of bending moment is a function of w and x. Okay, now my bending moment equation will be w, r and theta, because I am using the curved member. So let us see in this example what will be the bending moment at point B due to w and h. So what I require for bending moment? M into this lever arm. Now what is this? If this angle is theta, what will be my this lever arm? If this is theta and this is r, then this is r sin theta. So what I get in form of bending moment? W into r sin theta. As I told you in the previous video also, while using the Castigliano theorem, always use clockwise positive. So this is positive. Now what is the bending moment due to this H? This is H into this lever arm, means H, what is bending moment? H into AC. And what is this AC is equal to? This AC is equal to this AO minus OC. Okay. So what is AC? AC is AO, this complete length, minus this OC. Now what is AO? AO is the radius, so this is R. So this is R minus OC. Now what is OC? From this triangle you can say OC is R cos theta. So OC is R cos theta. So what is my bending moment because of this H? This is also positive clockwise. So H into R 1 minus cos theta. Okay friends. So what we get in totality for this? So how my theta is changing? Theta is 0 here and 90 here, 1/4 of the circle. So this up to this the theta is 90. So if I change it in the radian, what I will get? Pi by 2. What is my deflection in the vertical direction? So what I have to do? I have to write first the bending moment. First I have to write the bending moment equation. So what is my bending moment equation? It is W into R sin theta plus H into R 1 minus cos theta. Now for vertical, as per Castigliano, what I will do? Del M by del W. So what I get? R sin theta. Now as per the Castigliano theorem, what is my delta is equal to? Integration 0 to pi by 2 M. So M is W into R sin theta plus H into R 1 minus cos theta. This is my M. And what is my del M by del W? It is R sin theta. Then I will write in place of dx, I will place R d theta over EI. If you solve this integration, you will get delta. This is the way to find the vertical deflection of the curved member. Now let us take another problem in which I have to find the horizontal deflection due to the curved member. Now for the same case, how to find the horizontal deflection? So the case will be same. So delta horizontal will be integration 0 to pi by 2. This angle is changing from 0 to pi by 2. I am taking angle like this. Okay, this is very important. Now what is my bending moment equation? This is my bending moment equation. And what is del M by del H? I will be R minus R cos theta. So W into R sin theta plus H into R minus R cos theta multiply by R minus R cos theta divided by EI, and most important, in place of R, in place of dx, I will be putting R d theta. If you solve this, what you will get? Delta H equal to, solve this, what you will get? You will get 0.5 WR cube over EI plus 0.356 HR cube over EI. This is the way to solve the curved member. For horizontal member, as I told you just now, if you solve, what you will get? You will get 0.785 WR cube over EI plus 0.5 HR cube over EI. Let us take a combination of linear and curved member. So this is my curved member and this is my linear member. CD is my linear member. So what I will do? I will use the free body diagram concept. What is the free body diagram concept? The section here I can divide it into two parts. One is the upward W and anti-clockwise WR. Similarly, downward W and clockwise WR. Now, for this part, if I need to find the vertical deflection, then what I have to do? For AC part, this is my W and this is 1/4 of a circle. So I will take any point in between that and the angle is theta. So what is my lever arm? My lever arm is R sin theta. So what is my bending moment equation? It will be W into R sin theta. So what is del M by del W? It will be R sin theta. Okay. Then what is the integration? Integration is 0 to pi by 2. The angle is changing here to here. So this is 90-degree angle. So what I get? W R sin theta into R sin theta R d theta over EI. If you solve this part, then what you will get? WR cube over 4EI into pi. Now the second part. Second part is very easy, as I discussed in the previous video also. So a moment M is applied. What is why moment M is equal to WR and this load is axial. So I need not to consider the axial load. So this becomes very simple. This length is L. So what is my bending moment equation? It is WR. And what is del M by del W? It is R. Integration will be 0 to L because this is 0 and this is L. So integration will be 0 to L. WR into R into dx. Now it will be again changed to the dx because this is a linear portion over EI. So what I get when I solve? WR square, make it capital R, it hardly make any difference. So WR square over EI into L. So what is my total deflection? Total deflection is the summation of this and this. So this is my total deflection. In this way, friends, you need to solve the curved members. Now this is one question which I mostly teach when I am preparing the student for engineering services. If you want, you can solve it and check your answer because this is a bit lengthy question, and in GATE we don't find these type of lengthy questions, so I am just avoiding. But if you want to solve and want my guidance, you can WhatsApp me on the given number. I will be happy to clear your doubt. Otherwise, the solution is given in this. There is another problem which I have given to the students. I want you to solve these problems. This is one of the problem and this is the another problem. But only solve these problem if you are preparing for engineering services. If you are preparing for GATE, try to avoid these complex problem because they are very time consuming. Okay, fundamental is same, but it is little bit time consuming. So for engineering services in conventional, they might ask these type of questions. Otherwise, try to avoid this. I want to discuss one problem, but again this is a very complex problem and very time consuming. So what it says, now the angle is 120 degree and you have been given two loads, horizontal and vertical both. We have to find the ratio of h by w in such a way that delta hb is 0. Means horizontal deflection at b should be 0. So what should be the vertical load? What should be the ratio of horizontal to vertical load? Now friends, if you see, the complexity is like this, that up to this portion, I draw a horizontal line at C. So if you see, for this portion, this h is giving you the clockwise moment and w is also giving you the clockwise moment. But if you come below C, then what will happen? The h will give you the anti-clockwise moment and w will give you the clockwise moment. So you have to divide this integration in two parts. Rather than doing this, what I can do, you find the total moment at this point. And what that total moment is? Total moment is this length into w and h into this length. This is the fixed moment at A. I have calculated it for you and this comes out to be 0.866 HR plus 1.5 WR. So this is the moment, and because this is a fixed support, so I will get 1 W here and I get 1 H here. Now you apply the bending moment equation from this side. Clear? So what you are doing? You are applying the bending moment from A to B, not B to A. So your limit will be moving like this. And what will be your limit? 0 here and 2 pi by 3, which is equal to 120 degree. Now what is the bending moment equation? If you see, if you convert this, and then you write the bending moment equation. So if you write the bending moment equation, this is your fixed end moment. The moment W into lever arm. So what is my lever arm? It will be R minus R cos theta. And what is my horizontal lever arm at this point? It will be H into R sin theta. When you put the value and make the integration of delta HB, so what you have to do? You have to differentiate del M by del H. Okay, so put del M by del H equal to 0. So this whole expression will be 0, and when you solve, what you will get? You will get H by W is equal to 0.65. So friends, this is all about deflection of curved members. Thank you friends for watching this video. I hope you learned a lot of things. If you like this video, give a thumbs up and please write a comment for any suggestion which you want to give me. Also, you can WhatsApp me for any query or any doubt which you are facing while watching the video. Thank you. Enjoy civil engineering.